This morning we're in a late model JK with a 6-liter. This Jeep has a lot of options on it. Roll bar, trick suspension, it's got American flag paint job, which is pretty cool. Power everything, Banks gauge. What it doesn't have is an exhaust system. Well, it has an exhaust system, it just doesn't have any mufflers or converters as far as I know. The exhaust isn't too bad. We're going up the parkway, so it's a little loud, it's under a load. But once the load comes off, it's actually pretty mild. I thought this might be a good time to talk about powertrain configuration, because I think this is something that a lot of guys miss. And our mission goal has always been to stay true to the GM powertrain for many reasons. One of the reasons is if you have an all GM powertrain, you can service it, program it, tune it, just like you would a stock vehicle. There is no hybriding, there is no hacking and patching. In the early days, the Hemi guys would patch a V6 computer to be a Hemi. And they still do that, however, it's gotten a lot better. So the Hemis integrate pretty seamlessly. But if we look at it from an engine performance standpoint, and just so you guys know, I was a high-level emissions inspector, a G2 level inspector for 20 years. I worked in California, and we did some executive orders, which we're going to talk about. I'm going to wait to get to the top of the parkway here, because this 6-liter is a little bit loud under a load. Okay, I think you can see how much quieter it is now that we're off the throttle. So the powertrain configuration is very important. 1 for legality, and 2 for reliability, serviceability, diagnostics. Way back in the day when vehicles had like 10 wires, you had an ignition coil and a carburetor, it really wasn't that important. You could kind of mix and match components. In fact, we did a lot of Toyotas back in the day with V8s using the Toyota transfer cases. And the electronics were simple. The hardest part was the air conditioning. We actually integrated the thermistor and the AC clutch circuit control right into the V8, but that was about it. Everything else was simple. A power wire to the coil, maybe a choke on the carburetor, etc. But today things are very different. These engines are being run by computers and over a CAN network. And because a lot of you probably don't know, let's back up to 1995. In 1995, manufacturers had their own operating systems, which they still do today. Pretty much every manufacturer had their own protocol or computer language. So if you wanted to scan a Toyota or a Ferrari or a Chevrolet, you had to have different scanners, different adapters, different connectors, and it was really kind of a mess. And one of the few things that I think the federal government did that was really wise was they said, we got to standardize this. We got to standardize testing. And in California, Bar 90, which is pretty much the Bureau of Automotive Repair 1990 testing, there was a tailpipe test where you would put a probe in the tailpipe and you would check it at idle and cruise. You would check for hydrocarbons and carbon monoxide. Those are both bad gases. You would do a tampering inspection to make sure you had the gas cap, catalytic converter, air injection system, Egr valve, whatever was required on that vehicle. Really, by the mid-60s, the engines were cleaned up dramatically by the introduction of the positive crankcase ventilation or PCV valve, which replaced the road draft tubes. And they started to get nuts with emissions. Like the air injection systems came out in the mid to late 60s. And you see these beautiful 427 engines with 3 carburetors and a big air reactor or air smog pump on it with smog trees. And it just kind of ruined the whole thing. Secondary air was the complete combustion, because those engines, especially with big camshafts, were not very efficient. We weren't running 98% efficiency. So bad gases like raw gas, hydrocarbons, and partially burned gas, carbon monoxide would get into the exhaust. So what do you have in the exhaust? You have heat, you have fuel, and the third part of the fire triangle is oxygen or air. So if you introduce some air into the exhaust, you could complete the combustion before it went out the exhaust pipe. Then in the early 70s, the Egr valve came around, and that's a whole story in itself, because they started leaning motors out to get them to run cleaner and cleaner. But then they started to see smog, and I did live in the LA basin at that time. This brown haze get worse and worse, and they didn't realize what they were doing is they were creating NOx, or nitrides of oxygen, and we'll talk about that later. So the Fed said, we got to have a more efficient testing system. And you know, Kia, Mitsubishi, Honda, Chrysler by that time had their CAN system, which had a separate connector for the early Chrysler systems, and they did some weird stuff. Remember the old Concords and Mitsubishis with that early CAN system? So as far as engine performance goes, you must speak this one language. And of course there's a couple of different languages, but you have to standardize to one of these. And that way there would be one 16-pin data link connector for all vehicles. Now manufacturers had the right to use multiple data link connectors. In fact, we do that today. In the 90s, it was really popular to have multiple data link connectors. One for the ABS system, one for the CAN system, one for engine performance. But pretty much they started to rationalize it down to one connector, which most vehicles have today. And one of the reasons they can do that is CAN, or Controller Area Network, which is essentially a vehicle bus. And they're using it in everything today. Airplanes, heavy equipment, automobiles, you name it, they've got it. What does CAN do? Well, in 1996, the feds standardized the language and the connector so that emissions tests could be done more efficiently. And that was called Onboard Diagnostics 2, or OBD2. Onboard Diagnostics 1 came out in about 1981, and Onboard Diagnostics 1 was very limited. What it was doing is it was putting the diagnostics on board the vehicle instead of off board. Because prior to that, pretty much any kind of diagnostics had to be done using a lab scope or a handheld scanner and pull information out of the vehicle for the technician to diagnose it. In 1981, when Onboard Diagnostics 1 came out, it required the vehicle to store certain information that would help a technician diagnose a problem. Onboard Diagnostics 2 took that to a whole new level. Onboard Diagnostics 2 had onboard monitors so that the different systems, catalytic converters, oxygen sensors, fuel system, would have data or parameters, PIDs, TIDs, Mode 6 data that would monitor the systems as you drove. And they would complete after a drive cycle. Now, a drive cycle might not just be one trip. It might be 2, 3, 4 trips with overnight temperature changes, especially with EVAP systems. So you had onboard diagnostics that was monitoring your vehicle. Then all a technician had to do was tap into it for an emissions inspection, and any problems would be reported. So the inspector would plug in, and first he would make sure the monitors were set. Because if the monitors weren't set, then you don't know if all those tests were run. Different states have different rules, but most states will allow you 1 or 2 monitors to be unset and still pass an emissions inspection. Now when the monitor's set, you got to make sure you have no DTCs, or digital trouble codes. Trouble codes indicate there's a problem. It could be anything. It could be EVAP, misfire. There's hundreds, if not thousands, of trouble codes. So one of the problems in the early swaps in California, and I met with the authorities in Carson City, was mainly with the Hemi guys, the monitors, the machines we were using were only looking at the monitors that were supported. So if you had 6 of the 9 monitors supported in a Hemi, and a couple of them wouldn't set, they would just go in and turn those monitors off, which you can do with aftermarket software. Now you see the problem the Fed has trying to go after these aftermarket calibration devices. So prior to 2015, you take your Hemi in, you'd have no codes, you would pass. And none of the monitors were set because none of the monitors were active. In about 2014-15, I met, like I said, with the authorities, and they came up with a new process called CVN testing, calibration verification. And what that does is it looks at the factory operating system. And the factory operating system has calibration verification numbers. And these numbers are made up of checksums. And without getting too technical, they can literally compare the factory tune to the tune in your vehicle. And if it doesn't match, they know it's been modified. Because the emissions labs, especially in places like Colorado and California, have online access to the manufacturer data. So when they plug your vehicle in and they compare that CVN to the manufacturer CVN, it's black and white. It's really easy to tell if that vehicle was modified. So that pretty much blew turning the monitors off out of the water. And where am I going with this? Well, one of the reasons that Motec wanted to stay pure GM is because we wanted to support all the emissions that GM supported. When a vehicle is sold by a manufacturer here in the US, it has to go through the federal testing. The US EPA tests the vehicle and approves it. It's a US EPA production vehicle. And then it is, of course, graded on what is the gross vehicle weight, what are the emission outputs, the CAFE standards, and then the manufacturer can legally sell it here. If you do an engine conversion exactly to that standard, to the US EPA standard for a production vehicle, then you're good. And that's why Motec was committed to staying legal to US EPA guidelines. Now, when the CVN testing came out, that pretty much blew a lot of the other conversions out of the water. Of course, a lot of the country doesn't have IM or emission monitoring testing like California and Colorado, but every year we're seeing more and more of it. Arizona, Oregon, Wisconsin, back east, Massachusetts, New York. A lot of those states now require what's called an executive order for an engine conversion or any vehicle modification. And we'll talk about that later. I'm not sure we'll get to that in this video because there's just so much to talk about. We're talking about why we went the way we did. So let's say we went with a hybrid, a GM engine and a Chrysler transmission. You're never going to get a CVN. You're never going to get a US EPA production vehicle with that combination. So technically it's not legal in all 50 states. Let's say you take a V6 computer from a JK and you import all the Hemi parameters to make it run right. Well, that's called a hacked or a patched calibration, because most likely the monitors and other emissions data are set up for a V6. You think you got a 6-cylinder and it's an 8. So a lot of that stuff's just not going to work right. Now, I do know that some of the bigger companies like AEV have worked things out with the US EPA, and that's great. I highly recommend that you determine what your need is for your jurisdiction and then look into what that manufacturer offers. By getting an executive order, essentially what it is law. It is legislature in California, the ARB, the Air Resource Board, that inspects a vehicle just like the US EPA would inspect a production vehicle, test it, and certify it for registration in California. Now, the executive order, as far as I know, is followed by all jurisdictions in the country, at least every one I've dealt with so far. Then you're safe. What you have now is a conversion that's not only following the US EPA guidelines, so you have to look at this conversion as if Motec is a manufacturer, and we assign CVNs that get approved by the ARB, just like GM would assign CVNs that get approved by the US EPA. Once those CVNs are documented, you can now register your Jeep pretty much anywhere. And if a CVN test is required, like Colorado or California, you're going to be good. Just like a production vehicle, though, if you modify that vehicle, you put a cam in or an air intake in, you change things, then the CVNs won't match, and of course you're going to fail. So maybe it's a little more clear why Motec chose to go the route we did. It's not the easy way, it is the hard way, but it is also the legal way. And there's a lot of other side benefits. By going this route, we have a factory engine harness, and OE engine harnesses are just the best. Not only are they tested, but they have all the multiple redundancies for failure modes. You've got multiple injector signals and backups and coil backups, so if one burns out, I have harnesses in the shop that have 2 fuses, 1 relay, powering the entire harness. You have 1 injector short out, you're done. You're on the side of the road. With multiple failure modes, you keep going. You might be a 7-cylinder, but the OE operating system is smart enough to know that that cylinder is misfiring, shuts that injector off, and you get home. In addition, the OE harnesses have better ground and power distribution. You get grounds going everywhere. You look at some of these reduced circuit harnesses, they're much simpler. They just don't have the robustness of a factory harness. Then you get factory support. When you're using factory calibrations, you can hook up factory software and program your vehicle, diagnose your vehicle. Wiring harness colors are the same. Trouble codes are the same. You throw a fuel pressure sensor circuit code. You look it up and you diagnose it exactly the same you would in a production vehicle. Another advantage is the GM powertrains, to me, are just second to none. There's really no other V8 conversions out there running direct injection, 11.5 to 1 compression, continuous variable valve timing, low friction technology that these LT engines are using, 10-speed transmissions that are not only have low inertia or lower weight on the reciprocating mass, but you got 10 forward gears to choose from. You add it all up and you have a powertrain that just really is one step above everything else, in my opinion. And when you drive an LT1 10-speed, it shows. Now we're driving a 6-liter 6-speed, and it's awesome. This Jeep has got plenty of power, plenty of noise. It sounds like a V8. It pulls like a V8. This guy's going to be really happy. And it's running really cool, which I'm a little surprised at. As you can see, we're around 192 degrees. He does have a cold air hood, and I think his fender wells and all that are well vented, so it's running cool. Air conditioning on a pretty warm day here in Vegas. So when it comes to powertrain configuration, you want to go with something, one, that is OE. That means original equipment. By going with something that's all OE, parts are going to be more readily available, service is going to be more readily available, programming, tuning, diagnostics is all going to be easier to do than if you have some hacked computer or hybrid powertrain with adapters and trigger wheels and things like that. Throwing a supercharger on a V6 is definitely not OE. Superchargers can be legal. Some of them have certification. But what you're getting really is a compromise to a V8. You're never going to get the longevity, the reliability, the sound, the throttle response that you're going to get in a V8. So again, Motec's philosophy and mission goal from the very beginning was steered by my desire to stay as true as we could to the powertrain, and then everything else around it would have to comply to that. And by doing that, we have no compromise in the powertrain. The hard part was making the Jeep communicate with the GM, and early on it was hard. We did not use CAN technology, we used analog digital. We made pretty much everything work, but it was complicated. By adding a CAN module, all we're doing is adding one more module to the network. And as you know, some of these Land Rovers or Mercedes have 60, 70 modules. Now, all of them may not be on the same network. You have high-speed engine performance networks and lower speed serial networks and interior networks like the LIN bus. However, you got modules everywhere. So Motec's solution was to keep the GM system uncompromised, the way GM intended it to run, the way it's legal, the way the US EPA tested it, the way it can be serviced and diagnosed. Then interface that with the vehicle. And we did that through the MoCAN module, which is essentially a bidirectional bridge. It allows CAN packets to go from the GM to the Chrysler and Chrysler to the GM for the signals that are required. Things like air conditioning signals. Here, I'll pick one out. Evaporator temperature and AC request. When you turn on the air conditioning in your Jeep, it sends a CAN message. It used to send it through the cluster. Now, on the newer ones, like the one I'm driving, it's done through the HIVAC module. It sends a signal on the bus and says, hey, the air conditioner is being requested on. Now, there's qualifiers for that AC command or relay command to turn on. You got to make sure that the AC pressure is within range, that the evap temperature value is where the compressor needs to be on, because Chrysler pretty much cycles their evap temperature between 40 and 46 degrees, which gives you an outlet temperature of about 45 degrees average. And that's really good. If you try to go too much cooler than that on a humid day, you're probably going to freeze the evaporator up. So what we do is we simply get that AC request out of the CAN and tell the GM computer the AC is requested on, just like the HIVAC controller in a Silverado would do. Then the evap temperature in the Chrysler obviously says compressor on, compressor off to keep it in the temperature it wants. We send those same signals to the GM side that cycle the air conditioning, so you get OE performance. The last part of that puzzle is the AC relay command, which is inhibited by things by overheating, over revving, like if your RPM is too high, and all that's built right into the OE system. So it's about as non-invasive as you can get. We're no longer running any switches or trigger wheels or hybrid adapters or anything like that. The GM engine is running the way it wants to run and the way it legally needs to run. The Chrysler side doesn't know anything has happened. It's just operating the way it always has. We do not modify the Chrysler side. We don't modify the TIPM for one-touch start. We don't reprogram anything, which means you can literally plug into it and again diagnose it, program it just like you would a factory vehicle. So you got both sides happy now. Neither side was hacked, neither side was patched, neither side was modified. They're just both running the way they should, and then you have an interpreter in between. And it was hard to get where we're at right now. There were other approaches that were easier by just putting a Hemi engine in, but in my opinion, always being a GM guy, the lighter weight, more compact, higher technology GM engines, and especially the higher tech GM transmissions made it worth going to the GM powertrain. The GM engines are lighter and the vehicle dynamics are closer to the OE JK, and all the other benefits we talked about as far as legality and diagnosing and troubleshooting and all that. Now, I touched on the executive order and staying legal, and that's kind of a whole video on its own, so I'm going to be doing that coming up soon, because I know more and more of you guys are calling me and asking or writing in, I need an emissions legal swap. My county is going to emissions testing. So I'm going to try to address that in the near future, and just know that that was one of the prime considerations when we started doing engine conversions many years ago. Myself, being an emissions inspector for so many years, working in California, I know the importance of that to a lot of you guys. Now, if you're in Florida or Alabama or whatever, and you don't have emissions requirements, or you live in California, you're going to register your vehicle in Montana or something like that. That's kind of where people have gone for the last decade, but that's not where we were at. We always wanted to stay legal and within the law and get you that V8 engine conversion. And that is primarily one of the reasons that we went the route we went. So we're going to take this 6-liter up to the mountain, and we'll be back soon.